As we already discussed about microcontrollers and microprocessors, now we are going to compare the difference between microprocessors and microcontrollers. Let's have a look at the differences between microprocessors and microcontrollers. The first one. So, microprocessor is a silicon chip consisting of CPU and ALU unit, arithmetic and logical unit, and having some set of instructions to operate. Means microprocessors having one silicon chip which is a processor which consisting inside as CPU along with arithmetical, logical and operations which can be performed by using ALU. While it is coming to microcontrollers, it is also consisting of one IC, that is microcontroller, let it maybe 8051 plus, as usual inside 8051 for performing the arithmetical logical operations it needs one CPU, along with this memory, random access memory, RAM, to perform the input and output operations by using any one of the input or output devices support, and which we used to call it as ROM, and here we used to call it as program storage. So, program storage we used to call it as hard disk. ROM is also available, and the timer. Why we need a timer? To perform any one of the instruction it needs some time. For example, I have instruction 1, instruction 2, so on to instruction n. I can't able to execute all the instructions at a time. So, I will fix the time slots for this is for first second, and instruction 2 for 3 second, third second, and if instruction 3 is available, it has to execute at 5th second, and like that it has to execute at nth second. Means at which time instant which instruction has to be executed could be decided already by using the timer. And internal control units which used to perform by using CPU, RAM, ROM and timer also. Once you can perform the entire operation, you need to execute by using either it may be input device or it may be an output device. We used to commonly call it as input or output devices. Either it may be an input device or it may be an output devices. So, let us have a brief description in between 2 points. If it is microprocessor, it consisting of one silicon chip which we used to know as processor, and in this chip we have one CPU to perform all the arithmetical logical unit operations only. If it is in a microcontroller, it is consisting of one IC which is a microcontroller along with CPU, RAM, ROM, timer and IO devices support also. This is the reason why microcontrollers can support to execute any one of these specific applications. Let us have the second difference. Microprocessors is a time dependent, is a dependent unit. Yes, of course. Any one of you know how it is possible? Because in microprocessor, we have one processor which consisting of CPU to perform all the arithmetical logic operations only. Whenever it needs any one of the input, it needs an input device. At the same time, to execute any one of the output or to display any one of the output, it needs an output device. We commonly call it as I/O devices. And to perform entire operation, it needs the support of RAM, and to store the particular programming memory, it needs ROM, and the entire operation is executed based on time slots, timers. Means microprocessors needs the support of I/O devices, RAM, ROM, and timer. While it is coming to microcontroller, as we already discussed about of microcontroller already consisting along with CPU and RAM and ROM and timer along with I/O devices support. These all the elements are already inbuilt in microcontrollers. While it is coming to microprocessors, we do not have any external elements. So it is always a dependent unit. It is self-contained unit. It already having all the parts inside the controller. And next one is, it requires the combination of other chips. Means whenever you need to perform one task by using microprocessors. So microprocessor is a simple processor which we are using in our personal computers, a general processors. So it always needs combination. If not, it can't able to operate. So the combination should have any one of the chips to perform tasks, and program memory, data memory, and then interrupt controller to execute the functioning of entire processor. I'll consider one example. I have one PC. I need to run one program, so I have one software. So let it maybe Xilinx. So I just written one program in Xilinx to execute one design of an IC. Once it is completed simulation, after simulation I have 0 errors and 0 warnings. Means that particular program do not consisting of any one of the errors and warnings. So now this particular program is ready to execute in hardware domain. Then I will consider one VLSI processor or kit, Spartan 3S250. It's just one of the version of your Xilinx kit. So then this Spartan kit has to maintain some connection with PC. PC is nothing but your microprocessors. It has to maintain some connection with microprocessors. Then your processor has to dump the code, simulation code, into the Spartan kit. Then it can execute. The same thing cannot be performed by using microcontroller because it is always self-dependent. It can't able to operate. So it requires the combination of other chips like timers. Timer is for at which extent, at what time, which statement or which instruction has to be executed, has to be decided by the timer. And the program memory to store the entire program, let it maybe 5 to 7 lines of program. So entire program, and the data memory, which is an input memory, input data to this particular program, and interrupt controllers. So this depends upon whether we need interrupt controller or we don't want any interrupt controllers. That we have to manually will decide. And these are all to execute the proper functioning. While it is coming to microcontrollers, it does not require any external interrupt controllers because here you need interrupt controller. But here there is no need of any interrupt controller. no need of timer because it's already having a timer. And UART, universal asynchronous receiver and transmitter. So all these components, timer, interrupt controller, UART, don't want by microcontroller because already having inbuilt. While it is coming to microprocessors, it needs everything. Next one is microprocessor general purpose in design and operation. Design means, so I have 8085 or 8086. So which is an example of microprocessors. So as you already studied in microprocessors and microcontrollers, the architecture of 8085 is consisting of BIU along with EU. BIU means bus instruction unit, and this one is execution unit. So here entire instructions are traveling from one place to another place, like memories to processor, ALU to memory, memories to output devices. And once the entire operation performed by BIU, then that can be an input for EU, execution unit, where the code is loaded. Statement 1, 2, 3. So I have n lines of program. For this particular program, entire inputs taken from the BIU, and then once inputs has received EU, execution unit will execute the output. So it's a pure general purpose in design and operation, whichever it may be the microprocessor, 8085, 8086, 80285, 286, or 80386, or 80486, or 80586. We used to call it as Pentium. Pentium 1, so next Pentium 2, next 3, next 4, or it may be core to dual, or dual to core, or i3, or i5, or i7, or it may be latestly i10 also. Whichever it may be the processor, the internal architecture must consisting of BIU and EU, bus instruction unit and execution unit. There may be a chance, once the technology is getting advanced, there may be a chance to change a little bit architectural internal components, but the execution part is same. So any processor has to be segregated by using two parts. First one is BIU, next one is EU. Let's come to the microcontrollers. So this one, we can't able to decide the internal architecture because that's always depends on application oriented. So that is application oriented. For example, I have one application. For this, I may have one 8051 microcontroller having a RAM of 4 GB and internal hard disk is 64 GB, and it has a clock speed of 2.4 gigahertz timer. So let it may be the specifications for my application 1. For this type of application execution, I may follow one type of architecture in microcontroller. For example, I have one more application which is irrelevant to A1. Here also, I may have an opportunity to use 8051, but my RAM 4 GB not sufficient, maybe. So I'll go for 8 GB. 64 GB is not sufficient. Then I'll go for 256 GB. Then clock speed is not sufficient. Then I'll increase up to 3.3 gigahertz. So how much clock speed I need? That will be depends upon which application that I am going to executing or implementing. And the RAM, whether it may be 8 GB RAM is enough or not. Sometimes when you are using your mobile, you might be prioritized most of the times First one is how much is your RAM and what is your internal hard disk ROM and which is your processor. And sometimes you may go for display size. So I have a RAM, I have one mobile. I went for one shop and there I have seen one mobile consisting of 2 GB RAM and the hard disk is 64 GB. Whichever it may be the processor and whatever it may be the display size, this much of memory cannot be perfectly accessed by using 2 GB RAM. So I won't choose this one. So I'll go for some other mobile. So which having minimum of 4 GB RAM and having 64 GB internal hard disk and the processor is maybe MediaTek and display size is 6 inches. So there may be a chance because even I may have a 64 GB internal hard disk also, I have RAM is 4 GB. So there is a possibility to access the information which is consisting by 64 GB. Due to that, I will go for this mobile only, not for this mobile. So means my requirement. For example, I used to play a PUBG game in my smartphones when I am purchasing a new phone. Then 4 GB is also not sufficient for me. Maybe then I may go for 8 GB RAM consisting mobiles. So depends upon my requirement basis, the design will be decided. Okay? And the next one is does not consisting by the inbuilt I/O ports for microcontrollers. As I already told this, in microprocessors, input and output ports are not available. I have to take from external field. It doesn't consisting any inbuilt I/O ports. For this, I need to pay some finance. That is, I need to pay some amount of money. At the same time, money is for purchasing I/O ports. Once I have purchased, I need to take care when I am assembling those I/O ports to the microprocessors. So when I am assembling also, first I need some of the specifications. Maybe, let it maybe, I am considering USB ports, universal serial bus, pen drive ports. So initially it is having 1.0 versions. When we are using 8086 as a basic version, or let it maybe P4 generation type. So once the technology is improving, later we will come 2.0 versions when we are using i3 as our processor. But now 3.0 also came, which will be supported for i5, even it may support for i3 processor also. Of course, it is supporting i7 also. Means, what is this versions? This 1.0, USB 1.0, the speed is in terms of kbps, kilobytes per second only. It will transfer the data from CPU to pen drive or pen drive to CPU. And when it is coming to 2.0 version, the maximum speed comes from 4 Mbps. When you are transferring the data from CPU or hard disk or ROM to your external USB drive or else any external hard disk which is connected by using USB ports. If it is a 2.0 version, it will support up to 4 Mbps only. But recently 3.0 version has been introduced and it is supporting 16 Mbps data transfer rate. Means it is transferring the data from one device to another device 16 megabits per second. Means once the technology is improving, the data transfer rate is going to be increasing. By doing this, the time of utilization is reduces. Example, okay, I'm having 1 GB data in my hard disk. I need to transfer this 1 GB data to my pen drive. So if I am using 1.0 version, it will take hours of time. But the same data, 1 GB data, if I am using 2.0 version, means second version, it is supporting up to 4 Mbps. Per second it is supporting 4 megabits, means having 1000 megabits, 1000 by 4. So it's around 250 seconds. 250 seconds it will take. If I am using the same data, 1 GB data, by using 3.0 version, it is supporting 16 Mbps, means the same 1000 has to be divided by using 4. 4 2s are 4 2 5s are, so it is coming 125 seconds. Just check out the time duration, how much it is going to be reducing. Here you are using minimum of hours of time. Here 250 seconds. Here 125 seconds, means with less amount of time we are transferring the data from one device to another device is more and more. And when it is coming to microcontroller, it is already having I/O ports, either it may be 16-bit or 32-bit or it may be 8-bit also. Means this 1.0 or it may be 2.0 or it may be 3.0 or it may be any one of the I/O ports has to provide the facility to this microprocessors. Means we need to purchase it and we need to assemble to give the support to the microprocessors. When you are assembling to the microprocessors, you need to consider the speed of the microprocessor should has to match with USB speed also. Means for example, you are using only 8086 processor as processor, but still you are using 3.0 as your USB port. Is it possible to transfer the data by using 8086 processor through 3.0 version USB port? No, it won't possible. It won't support. At the same time, I am using i5 processor and my USB is 1.0 version I am using. So this speed is 3.4 gigahertz time frequencies. But this is having a support of 1 volt only, 1.0 version only. Again, the data transfer rate will not take place properly. That technical knowledge we must contain when you are assembling microprocessors along with any one of the devices. Either it may be USB ports or it may be I/O ports or it may be any I/O devices, anything, whichever it may be the component that you are giving or creating any interface between microprocessors and that particular device, you must consisting of technically sound knowledge whether processor having a support with this external device or not. And the next one is microprocessors target is high-end market. Target for high-end market where performance is important. Means microprocessors always PC or laptop. So nowadays everyone using minimum of 8 GB RAM plus minimum of 2 or 1 TB hard disk, terabytes hard disk. But in previous days, there is no availability of 8 GB and 2 TB, 1 TB hard disks. Then everyone may be using for 2 GB RAM along with 500 GB hard disk. And either maybe 5 years before, there is no terabyte hard disks are available. So at that time, everyone has to use 500 GB hard disk with 2 GB RAM only. So high-end market is nothing but where more number of people are willing to purchase for that particular cost. For example, as we are already having laptop, 8 GB RAM with 1 TB hard disk, let it may be. Its cost around let maybe 30K. So some other company is releasing the laptop, the same 8 GB RAM plus 1 TB hard disk is for only 26,000, which giving the same performance as like this one. Both are giving same to same performance. There is nothing difference in between these two. But still somewhere somehow the company people reduced the cost to 26,000 and this maybe 30,000. Obviously we are going to choose to purchase 26,000 rupees laptop only. Means everyone has analysis, financial analysis. Less amount, the same performance is providing by this laptop, but the same performance providing by this one is you need to provide 30,000. So I used to prefer to purchase this one only. That's the high-end market where more number of people are concentrating. Obviously money and the second one is performance. Once the performance is good, then obviously both are same. For example, here you are using processor as i3. Here I am using processor as i5. Obviously the performance of i3 is not greater than performance of i5. i5 only much better performance is giving rather than i3. Then even it may be 4,000 high also, I used to prefer to purchase i5 processor laptop only. Then I'll go for 30,000 laptop only. So that again depends upon requirement. But it is coming to microcontrollers, target is only for embedded market. Embedded market means there is nothing like performance we can't able to calculate on this much of hard disk, this much of RAM, and this RAM, this hard disk. We can't able to fix it because microcontrollers are always application oriented. If I need one device or if I need to manufacture one more mobile with high configuration, then obviously the target must be too high. Then if I'll be the vendor or I may be the client, then I'll choose to prefer one mobile, 16 GB RAM and having 256 GB hard disk along with i10 processor. If possible, the entire laptop has to around 45K. That's my priority. I don't know whether it may be possible or may not be possible. That part has to be taken by the designers. So if I am the client, this is my application. I just need one laptop with 16 GB RAM, 256 GB hard disk and i10 as a processor. Then I'll use to, my purchase price is 45,000 only. So that's always depends upon application basis. And next one is, in microprocessors, there is no power saver mode, power saving options. Have you ever seen any one of the PC or laptops before 2015? Any one of the PC or laptop before 2015. So in our systems, any option like power saving or 2015 before laptops also does not have power saving mode. They does not have any power saving modes. But after getting 2015 October, laptops having two modes, balanced power option or power saving option. We have two options in our laptops also. So means balanced means it will provide the display brightness up to minimum 30%. But if it is power saving mode, the same display will come 15%, means the display giving the brightness less than 15% means the power usage of a battery in our mobile, or it may be in a laptop, is going to be reducing. If it is in balanced mode, in your mobile, in background, lot of apps are running. But if it is in power saving mode, no apps are running. Only it is displaying incoming and outgoing only. It will accept the power saving mode. But if it is a microcontroller, includes lot of power savings. Means nowadays we are using smartphones. Everything is based on power saving features only. So next one is microprocessors. High processing power means microcontroller, when you are using any one of your system or laptop, it needs 220 volts DC supply voltage plus 50 Hz of frequency. It must needs by the microprocessors. But if it is a microcontroller, whichever it may be, when you are disconnecting power supply also, means you are not using any power supply, you are using based on battery. So battery, let it may be 4400 mAh, but it will provide only 3 volts, 5 volts, 12 volts, maximum up to 18 volts. But laptop will not allow 18 and 12, either it may be 3 volts or it may be 5 volts only. But here we are using 220 volts DC as a supply. But here I am using only either 3 volts or 5 volts from battery. That's the reason why here low processing power request for controllers. If it is a processor, high processing power is required. Microprocessors typically used 32 and 64-bit operatings. Nowadays, we have operating systems for every system. When you are formatting your OS, it will ask, you need 32-bit OS or 64-bit OS. Depends upon your priority basis, you can format whether you need 32-bit or you may need 64-bit. Whichever you need, you can format with by using either it may be 32-bit or it may be 64-bit. But if it is a microcontroller, minimum is 8-bit and maximum is 16-bit only. There is no place for 32, 64, 128. These are all not permitted for microcontrollers. Thank you.